A seismic signal from the moon has just sent shockwaves through the scientific world, and Michio Kaku isn't mincing words. He's calling it a wake-up call for humanity. Kaku warns that this unexpected tremor could mean the moon's core isn't as dormant as we once believed, raising the stakes for both lunar science and life on Earth. Did you know the moon's gravitational pull actually helps stabilize Earth's climate and tides? If the moon is changing, so could our world. Here's a question. Did you know the moon's core might still be active? Seismic signal discovery. A seismic signal on the moon has just thrown the scientific world into a frenzy, and Michio Kaku isn't holding back his concerns. This isn't your average moonquake. This signal was so unexpected and intense that it's forcing scientists to rethink what's happening deep beneath the lunar surface. Kaku, a leading voice in theoretical physics, jumped into the conversation, warning that the moon's core might not be as dormant as we once believed. He explained that for decades experts assumed the moon was geologically dead, but this seismic activity hints at a mysterious force stirring within. The implications go far beyond curiosity. The moon's core plays a crucial role in stabilizing Earth's tilt and controlling our tides. If something is shifting inside the moon, Kaku warns, it could have ripple effects right here on Earth. Subtle changes in our tides, maybe even our weather. What's even more fascinating is that this seismic event doesn't fit the usual patterns caused by meteor strikes or temperature changes. Thanks to advanced sensors from recent lunar missions, scientists are now picking up signals that were invisible during the Apollo era. Kaku's message is urgent. We're standing at the edge of a new era in lunar science, and we need to pay attention. As researchers scramble to decode the moon's signals, one thing is clear: our closest neighbor is keeping secrets, and those secrets might be more important than we ever imagined. Michio Kaku's immediate reaction. When news broke that Michio Kaku had responded to the moon's seismic signal, curiosity skyrocketed across the globe. Kaku's immediate reaction was far from casual. He called the event a wake-up call for scientists everywhere. He emphasized that this wasn't just another blip in lunar data, it could be the first sign of a deeper transformation inside the moon. Kaku's words carried weight, especially as he explained that such seismic activity might point to an awakening of the lunar core, a region long thought to be frozen in time. He urged the scientific community not to underestimate the importance of this signal, warning that ignoring it could mean missing out on a fundamental shift in our understanding of the moon. According to Kaku, the rarity of this event is precisely what makes it so alarming. He drew attention to the fact that our technology has finally reached a point where these subtle signals can be detected and analyzed in real time, making this discovery even more significant. Kaku's passionate call for vigilance resonated with those who understand the interconnectedness of celestial bodies. He made it clear that the moon's fate is tied to Earth's in ways we're only beginning to grasp. As his warning echoes through the halls of science, the world is left to wonder, what else is lurking beneath the surface of our lunar companion, and are we truly prepared for the answers that might emerge? Why the moon's core matters. Beneath the moon's familiar glow, a hidden drama is unfolding that could rewrite everything we thought we knew about our cosmic neighbor. For decades, scientists assumed the moon's core was cold, still, and unchanging, a relic of ancient times. Now, Michio Kaku is sounding the alarm, arguing that the core's activity could be far more dynamic than anyone expected. He highlights how the moon's core, though small compared to Earth's, plays a vital role in shaping the lunar magnetic field and, by extension, the environment that shields the moon from solar radiation. Kaku warns that if the core is indeed waking up, we might see changes in the moon's magnetic properties, which could even affect future lunar missions and technology placed on its surface. The idea that the moon is still evolving deep beneath its crust challenges the long-held belief that it's a geologically dead world. Kaku's insights push us to reconsider the moon's entire history and its ongoing influence on Earth. He suggests that understanding these core processes isn't just an academic exercise, it's essential for predicting how the moon will behave in the future. As seismic signals continue to surface, the scientific community is left with a pressing question. Are we witnessing the rebirth of lunar activity, and what does that mean for humanity's next steps in space exploration? The moon's core, once thought silent, may be trying to tell us a story that's only just beginning to unfold. Potential impacts on Earth. Every so often, A discovery comes along that challenges the very foundation of what we think we know about our place in the universe. Michio Kaku is quick to point out that the moon's core isn't just a scientific curiosity, it's a critical piece of the puzzle that keeps Earth's delicate balance in check. The gravitational pull between the Earth and Moon does more than create tides, it actually helps stabilize our planet's axial tilt, which in turn keeps our seasons predictable and our climate relatively steady. If seismic signals are hinting at changes deep within the Moon, Kaku warns that even subtle shifts could have far-reaching consequences for life on Earth. He explains that a more active lunar core might alter the gravitational relationship between our two worlds, potentially affecting everything from ocean currents to weather patterns. This isn't just a concern for astronomers or geologists, it's a wake-up call for anyone who depends on Earth's natural rhythms, which is, well, all of us. Kaku's message is clear: we can't afford to ignore the moon's signals or assume that its influence ends at the edge of its cratered surface. As scientists race to decode what's really happening beneath the lunar crust, the rest of us are left to wonder how the moon's hidden changes might ripple through our own lives, subtly shaping the world in ways we're only beginning to understand. Historical context. A single seismic signal has upended decades of lunar research, leaving experts scrambling for answers. Michio Kaku draws attention to how past theories about the moon's seismic activity were largely shaped by meteor impacts or the slow cooling of its crust. But this new signal doesn't fit the old script. It arrived with a force and frequency that defies the usual explanations, hinting at processes deep inside the moon that scientists never anticipated. Kaku emphasizes that historically, moonquakes were thought to be rare and easily explained by external events. Now with this unexpected tremor, the scientific community is forced to consider the possibility of an active, evolving core. What's truly captivating is how this event challenges established models of lunar geology. Kaku's warning is that we may have underestimated the complexity of the moon's inner workings all along. The seismic anomaly stands as a stark reminder that even our closest celestial neighbor holds mysteries capable of shaking the foundations of planetary science. As researchers pore over the data, they're left to confront the uncomfortable truth that the moon's story is far from complete. The old assumptions are crumbling, and in their place is a new sense of urgency to understand what's really happening beneath the surface. For anyone fascinated by the unknown, this seismic event is proof that the universe still has plenty of surprises in store. Advanced detection technology. Lunar exploration has entered a new era, thanks to technology that's more sensitive than anything used during the Apollo missions. Michio Kaku highlights how recent advances in seismic detection have pulled back the curtain on the moon's hidden activity, capturing signals that would have gone unnoticed just a decade ago. These new instruments, deployed by international teams and robotic landers, can pick up the faintest tremors from deep within the lunar core. Kaku points out that this leap in technology is a game-changer. For the first time, scientists can monitor the moon's interior in real time, tracking shifts and pulses that reveal its true nature. The seismic signal that sparked Kaku's warning was detected by this new generation of sensors, offering a level of detail that's rewriting the textbooks. It's not just about spotting moonquakes, it's about understanding the moon's ongoing evolution and the forces shaping its future. Kaku stresses that these tools are opening a window into a world that, until now, was shrouded in mystery. The data pouring in is challenging assumptions and pushing scientists to ask bigger, bolder questions about what lies beneath the surface. As the technology continues to improve, Kaku believes we're on the brink of discoveries that could redefine our relationship with the moon, and by extension, our own planet's place in the cosmos. Unanswered questions. A single seismic signal has left scientists with more questions than answers, and Michio Kaku isn't shy about what's at stake. He underscores how little we truly know about the moon's interior despite decades of exploration and countless missions. The recent tremor has exposed a glaring gap in our understanding, forcing experts to reconsider long-held beliefs about lunar geology. Kaku emphasizes that this isn't just an isolated event, it could be the tip of the iceberg, a clue to a pattern of activity that's been hidden for millennia. He challenges the scientific community to confront the unknown head-on, urging deeper investigation and open-minded analysis. Theories are swirling. Could this signal be tied to ancient volcanic processes, or does it hint at something entirely new beneath the crust? Kaku's message is clear. Science thrives on curiosity and the courage to question. He warns against complacency, reminding us that every breakthrough starts with a mystery that refuses to be ignored. As researchers sift through the data, the sense of urgency grows. The moon, once thought to be a silent witness to cosmic history, may be far more dynamic and unpredictable than anyone imagined. Kaku's call to action is resonating across the globe, inspiring a new generation of scientists to dig deeper and listen closer to the stories written in the moon's seismic whispers. Theories and speculation. A seismic mystery on the moon has triggered a wave of speculation among scientists, and Michio Kaku is urging everyone to keep their minds open. Instead of jumping to conclusions, he highlights the need for careful analysis and a willingness to embrace the unknown. Some experts are already floating theories that this signal could be linked to ancient volcanic activity, hinting at a past where the moon was far more alive than we ever imagined. Others suggest it might be the result of the moon's gradual cooling and contraction, processes that could still be shaping its core today. Kaku cautions against settling on easy answers, reminding us that true scientific progress comes from questioning, testing, and sometimes overturning what we think we know. He points out that every seismic anomaly is a chance to uncover new layers of lunar history, clues that could reshape our understanding of how the moon, and even the Earth, evolved. The excitement is palpable as researchers debate the possibilities, knowing that each new discovery brings us closer to solving the riddle of our celestial neighbor. Kaku's call for patience and rigor is a rallying cry for scientists everywhere. Don't just look for what you expect to find, be ready for the unexpected. In this moment of uncertainty, the moon is offering up secrets that could rewrite the story of our solar system, and Kaku wants to make sure we're paying attention to every detail. Call for international collaboration. Global cooperation is suddenly in the spotlight as Michio Kaku calls for a united scientific front in response to the moon's seismic surprise. He's not content with isolated discoveries or fragmented research. Kaku insists that only by pooling resources, data, and expertise can humanity unlock the true meaning behind these mysterious signals. This isn't just a challenge for one nation or a handful of space agencies, it's an invitation for the world to work together on a cosmic puzzle that could affect us all. Kaku envisions international teams sharing seismic data in real time, cross-analyzing findings, and launching joint missions to deploy even more advanced sensors on the lunar surface. He argues that collaboration is the fastest path to breakthroughs, and that the moon's secrets are too important to be kept behind national borders. The urgency in his voice is unmistakable. If the moon's core is changing, the stakes are global, and so must be our response. Kaku's rallying cry is already inspiring new partnerships and conversations among scientists who might otherwise have worked in silos. As the world tunes in to this unfolding lunar mystery, the message is clear. The universe doesn't care about boundaries, and neither should our search for answers. In this new era of space exploration, Kaku's vision of global teamwork could be the key to understanding the moon and safeguarding our future on Earth. What's next for lunar science? A new chapter in lunar science is unfolding, and Michio Kaku believes the next steps could redefine our relationship with the moon forever. He's pushing for more than just analysis. He wants action. Kaku urges the scientific community to accelerate plans for deploying even more advanced sensors and robotic explorers to the lunar surface, arguing that only with a constant stream of real-time data can we truly monitor the moon's evolving core. He envisions a future where lunar bases double as seismic observatories, feeding information directly to researchers on Earth and enabling instant responses to any new tremors or anomalies. This isn't just about satisfying curiosity. Kaku warns that understanding the moon's inner workings could be critical for the safety of future astronauts, the protection of lunar infrastructure, and even the stability of Earth itself. The recent seismic event is a wake-up call, and Kaku's message is clear. The moon is alive with secrets, and it's up to us to listen. As new missions are planned and international collaborations take shape, the excitement is palpable. Each new sensor, rover, and data stream brings us closer to unraveling the mysteries beneath the moon's surface. For Kaku, this is more than science. It's a race to secure our place in the cosmos, armed with knowledge and united by a shared sense of wonder and responsibility. Thanks for joining me on this deep dive into the mysteries of the moon. If you found these insights as fascinating as I did, don't forget to subscribe to Space Facts for more mind-blowing discoveries from across the universe. Hit that bell icon so you never miss an update, and let me know your thoughts or questions in the comments below. Your curiosity keeps this community thriving, so keep those ideas coming. Until next time, stay curious and keep looking up. Hold up, Voyager 1 now drifts beyond 15 billion miles, where interstellar space pulses warmer than every model predicted. And here's a powerful insight: its radio whisper, weaker than a fridge bulb, still streams findings that are, honestly, rewriting astronomy. Humanity is steering a 1977 computer into the unknown, and it's winning. Quick check. Did you realize our whole solar system hides inside a supernova-carved local bubble acting as Earth's cosmic shield? Ever wondered what happens when we finally sail beyond it? New groundbreaking data. What if I told you that humanity just discovered we've been completely wrong about space for the past 50 years? Right now, as you're watching this, there's a tiny spacecraft called Voyager 1 floating 15 billion miles away from Earth, and it just sent back data that's making every space scientist on the planet question everything they thought they knew about the universe. We're talking about groundbreaking information that's literally rewriting textbooks as we speak. For decades, we assumed interstellar space was this quiet, predictable void between stars. You know, just empty darkness with the occasional cosmic dust particle floating around. But Voyager 1's latest transmissions are revealing something so unexpected that NASA scientists are having emergency meetings just to process what they're seeing. The magnetic field readings, the particle densities, the cosmic radiation patterns, none of it matches our models. It's like we sent an explorer to map a desert, and they came back telling us they found a bustling metropolis instead. What makes this even more incredible is that this data is coming from a machine that was launched back in 1977, that's 48 years ago, using technology that's now less powerful than the calculator on your phone. And yet, this ancient piece of human engineering is currently our only eyes and ears in true interstellar space, sending back revelations that are fundamentally changing our understanding of what lies beyond our solar system's protective bubble. Unexpected patterns, galactic rays, and cosmic pressure. What if everything we know about cosmic radiation is backwards? Voyager 1 just dropped a scientific bombshell that's got researchers scratching their heads and pulling all-nighters at observatories worldwide. The galactic cosmic rays hitting our probe aren't behaving like any computer model predicted. They're doing something so bizarre that physicists are literally calling it impossible based on our current understanding of space. Here's where it gets wild. The cosmic pressure out there in interstellar space is fluctuating in patterns that suggest there's some kind of massive invisible structure influencing everything around us. We thought space between stars was just a uniform soup of particles and radiation, but Voyager 1's instruments are detecting organized waves, almost like cosmic weather systems that span light years across. The magnetic field measurements are showing twisted, braided patterns that look more like DNA than anything we expected to find in the void. Even more mind-blowing is that these unexpected radiation patterns seem to be connected to events happening billions of miles away. It's as if interstellar space has its own nervous system, with galactic rays carrying information across vast distances in ways we never imagined possible. The particle detectors are picking up rhythmic pulses that scientists are now calling cosmic heartbeats, and nobody can explain what's causing them. This isn't just academic curiosity anymore. These discoveries are forcing us to completely rethink how galaxies communicate with each other and what role our solar system actually plays in this cosmic network that we're only just beginning to understand. Digital CPR. NASA revives a dying spacecraft. You're about to witness the most incredible rescue mission in human history, and it happened 15 billion miles away. When Voyager 1's computer started glitching in November 2023, sending back nothing but gibberish data, NASA engineers faced an impossible challenge. How do you fix a spacecraft that's so far away, it takes 22.5 hours just for your commands to reach it? This wasn't just any malfunction. The probe's flight data subsystem had corrupted, essentially giving the 47-year-old explorer digital amnesia. The NASA team at Jet Propulsion Laboratory had to become cosmic surgeons, performing what they brilliantly called digital CPR on humanity's most distant ambassador. For months, they sent carefully crafted code patches across the solar system, each attempt taking nearly 2 full days to confirm whether it worked or failed. The tension was unbearable. One wrong command could permanently kill our only functioning probe in interstellar space. But here's the jaw-dropping part. They didn't just revive Voyager 1, they actually improved it. The engineering team managed to relocate critical software functions around the damaged memory sectors, essentially performing brain surgery on a patient they couldn't even see. When the spacecraft finally came back online in April 2024, it wasn't just alive. It was healthier than it had been in years. This digital resurrection proves that human ingenuity knows no bounds. We literally brought a dying machine back to life across a distance so vast that our entire solar system would look like a grain of sand from Voyager 1's perspective. A new kind of map, Voyager's role in galactic GPS. So, we just created the universe's first GPS system, and honestly, you'll never guess who's running it. Voyager 1 has, kind of by accident, become humanity's cosmic navigation beacon, creating the most detailed map of interstellar space that's ever existed. While GPS satellites orbit Earth at a measly 12,500 miles altitude, our little probe is charting territory 15 billion miles from home, basically becoming the galactic GPS that future space missions will rely on for centuries. What makes this absolutely incredible is that Voyager 1 is creating a three-dimensional map of space that no telescope could ever produce. Every mile it travels deeper into the interstellar medium, it's collecting data about magnetic field strengths, particle densities, and cosmic radiation levels that are building the most comprehensive database of what lies beyond our solar system. Think of it as drawing the first accurate map of an undiscovered continent, except this continent is bigger than anything humans have ever explored. The trajectory data and environmental readings Voyager 1 sends back aren't just scientific curiosities, they're actually becoming the navigation charts for future interstellar missions. NASA engineers are already using this information to plan routes for next-generation probes, calculating optimal paths through the cosmic landscape that Voyager 1 is currently mapping in real time. This accidental transformation from explorer to guide means that every future human venture into deep space will follow in Voyager 1's digital footsteps. We're not just exploring anymore, we're building the infrastructure for humanity's expansion into the galaxy, one data packet at a time. Interstellar weather, cloudlets, filaments, and the local bubble. There's actual weather happening in the supposedly empty space between stars, and it's nothing like anything on Earth. Voyager 1 has discovered that interstellar space isn't the peaceful void we imagined. It's a churning ocean of cosmic cloudlets, mysterious filaments, and invisible storms that span distances larger than our entire solar system. We're not just floating through empty darkness, we're sailing through what scientists are now calling interstellar weather that's more dynamic than Earth's most violent hurricanes. The most shocking revelation is that we've been living inside something called the local bubble this entire time without even knowing it. This cosmic cavity, created by ancient supernova explosions millions of years ago, is like a protective bubble around our solar system that's been shielding us from the harsher realities of galactic space. Voyager 1's instruments are now detecting the bubble's walls, massive shock waves and magnetic barriers that have been deflecting deadly cosmic radiation away from Earth for our entire existence. But here's where it gets truly mind-bending. These interstellar cloudlets aren't random. They're organized into vast filamentary structures that connect star systems across hundreds of light years, forming what appears to be a galactic highway system. The particle density measurements suggest these cosmic threads are carrying matter and energy between distant regions of our galaxy, creating an interconnected web that makes our local bubble just one room in a cosmic mansion we're only beginning to explore. We're not alone in empty space, we're inhabitants of a cosmic neighborhood we never knew existed. The legacy beyond the mission. What started as a 12-year mission has become humanity's most enduring legacy in the cosmos. When Voyager 1 launched on September 5, 1977, Jimmy Carter was president, Star Wars had just hit theaters, and the internet didn't even exist. Yet this incredible machine is still out there 48 years later, fundamentally changing our understanding of the universe and proving that human engineering can outlast entire generations of the people who built it. The golden record attached to Voyager 1 was supposed to be humanity's message to aliens, but it's become something far more profound, a time capsule of our species floating through interstellar space long after we're gone. While civilizations rise and fall on Earth, this little spacecraft continues its eternal journey, carrying the sounds of Bach, Chuck Berry, and children's laughter to the stars. It's not just exploring space anymore, it's become our ambassador to infinity. But here's what gives me chills. Voyager 1 will outlive our sun. Long after Earth becomes uninhabitable and our solar system dies, this probe will still be cruising through the galaxy, potentially for billions of years. The data it's collecting right now about interstellar conditions and cosmic radiation isn't just helping us understand space today, it's building a scientific foundation that will guide humanity's expansion into the galaxy for centuries to come. Voyager 1 has transcended its original mission to become something unprecedented in human history, our first truly permanent mark on the universe, still teaching us about cosmic mysteries nearly 5 decades after leaving home.
So what's really out there?
So we just discovered that the universe has been, well, lying to us about what's really hiding in the darkness between stars. Everything you've ever learned about interstellar space, that it's empty, cold, and lifeless, is, completely wrong. Voyager 1 has revealed a cosmic reality so strange that it's forcing scientists to throw out decades of assumptions and basically start from scratch. The space between stars isn't a void at all, it's teeming with invisible structures, mysterious energy sources, and phenomena that honestly make science fiction look boring by comparison. The most shocking discovery is that interstellar space is filled with what researchers are calling dark plasma electrically charged particles that create massive invisible rivers flowing between star systems. These cosmic currents are carrying matter and energy across light years in patterns that suggest the galaxy has its own circulatory system. Voyager 1's magnetic field detectors are picking up signals that indicate these plasma streams are actually connected to the formation of new stars, meaning the so-called empty space is actively creating the building blocks of future solar systems. But here's what's really mind-blowing. The temperature readings out there don't match any of our models. Instead of the predicted near absolute zero environment, Voyager 1 is detecting pockets of space that are like thousands of degrees warmer than they should be. These thermal anomalies suggest there are unknown energy sources heating up regions of interstellar space, and honestly, nobody can explain what's powering them. We thought we were exploring a cosmic desert, but Voyager 1 has shown us we're actually sailing through a hidden ocean of activity that's been invisible to Earth-based telescopes this entire time.
The technicals.
You're about to learn why talking to a spacecraft 15 billion miles away is harder than performing surgery blindfolded. The technical wizardry behind Voyager 1's operation is so mind-bogglingly complex that it makes rocket science look like elementary math. We're communicating with a machine using 1970s technology that has less computing power than a modern digital watch, yet it's sending back data that's revolutionizing our understanding of the cosmos across a distance so vast that radio signals take 22.5 hours to make the one-way trip. The Deep Space Network, NASA's array of massive radio dishes in California, Spain, and Australia, has to track Voyager 1 with pinpoint accuracy as it hurtles through space at 38,000 miles per hour. The signal strength reaching Earth is weaker than the power from a 20-watt refrigerator light bulb, yet engineers can still decode complex scientific data from this whisper-faint transmission. The radio receivers are so sensitive they can detect energy equivalent to a single snowflake hitting the ground. What's absolutely incredible is that Voyager 1 is still running on plutonium-238 power sources that generate less electricity than a car battery, yet this tiny amount of energy is powering instruments capable of detecting cosmic phenomena across interstellar distances. The flight computers have just 69 kilobytes of memory, that's less storage than a single smartphone photo, but they've been flawlessly executing complex scientific operations for nearly half a century, while traveling through the most hostile environment imaginable. This isn't just engineering, it's technological magic that proves human ingenuity can literally reach across the galaxy.
Digital CPR aftermath and data recovery.
What if I told you that bringing a dead spacecraft back to life actually made it stronger than before? The aftermath of Voyager 1's digital resurrection in April 2024 didn't just restore the probe to its former glory, it transformed it into something unprecedented. After months of careful data recovery, NASA engineers discovered that their emergency repairs had accidentally optimized the spacecraft's performance in ways they never imagined possible. The flight data subsystem that nearly killed the mission is now running more efficiently than it had in decades. The data recovery process revealed something extraordinary. Voyager 1 had been storing corrupted information in its backup systems for years without anyone knowing. When the JPL team performed their digital surgery, they didn't just fix the immediate problem. They uncovered a treasure trove of previously unreadable scientific data dating back to 2018. This recovered information is now providing scientists with a continuous 5-year timeline of interstellar conditions that fills crucial gaps in our understanding of cosmic weather patterns. But here's the most incredible part. The software patches NASA uploaded during the rescue have actually enhanced Voyager 1's ability to compress and transmit data. The probe is now sending back 30% more scientific information per transmission than before the crisis. The memory reorganization forced by the malfunction eliminated years of digital clutter, essentially giving the ancient computer a performance boost that's allowed it to operate with unprecedented efficiency. This digital comeback proves that sometimes the most devastating failures can lead to the greatest breakthroughs, turning near disaster into humanity's most successful deep space recovery operation.
The Cosmic Oasis Revelation.
We've been living in a cosmic paradise this entire time and had absolutely no idea. Voyager 1's most profound revelation isn't about the dangers lurking in interstellar space. It's about how incredibly lucky Earth has been for billions of years. The probe's journey beyond our solar system's protective bubble has revealed that we're not just floating in empty space, we're residing in what scientists are now calling a cosmic oasis, a rare pocket of the galaxy where conditions are so perfectly balanced that complex life can actually survive and thrive. The local bubble that surrounds us isn't just a random cosmic accident. Voyager 1's measurements show that this protective zone, created by ancient supernova explosions 10 to 20 million years ago, has been actively filtering out deadly galactic cosmic radiation that would have sterilized our planet countless times over. Without this invisible shield, Earth would be a frozen, irradiated rock floating through a universe hostile to any form of life we can imagine. But here's the truly staggering discovery. These cosmic oases are incredibly rare. The interstellar medium that Voyager 1 is now exploring represents the harsh reality of most galactic space, regions where radiation levels are thousands of times higher than what we experience inside our bubble. The probe's particle detectors are revealing just how extraordinary our little corner of the Milky Way really is. Voyager 1 didn't just show us what's out there, it showed us how precious and unique our cosmic neighborhood truly is, making us appreciate Earth's place in the universe like never before. So there you have it. Voyager 1 just proved that everything we thought we knew about space was completely wrong. While you're processing these mind-blowing revelations, make sure to hit that bell icon so you never miss our latest cosmic discoveries. Subscribe to Space Facts if you want to stay ahead of the universe's biggest secrets. And here's my challenge for you. Drop a comment below and tell me which Voyager 1 discovery shocked you the most. Was it the cosmic oasis revelation or those mysterious interstellar weather patterns? I read every single comment, so let's discuss what's really waiting for us out there in the cosmic unknown. While NASA and SpaceX dominate today's headlines about Mars exploration, the most daring attempts to reach the Red Planet happened 60 years ago behind the Iron Curtain. The Soviet Union launched secret Mars missions that were so advanced, so ambitious, and so catastrophically dangerous that, honestly, they make Elon Musk's Starship look like a neighborhood science project. These missions literally exploded on launch pads, crashed into alien soil, and vanished into cosmic silence, but they paved the way for everything we know about interplanetary travel today. Did you know the Soviets actually landed on Mars before anyone else, but it was completely by accident?
The beginning.
While everyone was obsessed with the moon landing in 1969, the Soviet Union was quietly plotting something far more audacious, a mission to Mars that would make Apollo 11 look like a neighborhood joyride. The space race wasn't just about planting flags on lunar soil, it was about who could conquer the ultimate prize, the Red Planet. Behind the Iron Curtain, Soviet engineers were designing spacecraft that could travel 140 million miles through the cosmic void, endure radiation storms, and attempt humanity's first landing on another world. This wasn't science fiction, this was Cold War reality. While Neil Armstrong was taking his famous first steps, Soviet mission planners were already calculating launch windows to Mars, designing heat shields that could survive atmospheric entry at 12,000 miles per hour, and developing communication systems that could beam signals across interplanetary distances. The Soviet space program had already shocked the world with Sputnik in 1957, and Yuri Gagarin's historic flight in 1961, but their Mars ambitions were on an entirely different scale. These weren't just orbital missions or lunar flybys, they were attempting to land functional spacecraft on a planet where temperatures swing from 70 degrees Fahrenheit to minus 195 degrees Fahrenheit, where dust storms can rage for months, and where one miscalculation means losing everything in the dark expanse of space. What happened next would change everything we thought we knew about the space race, and most of the world never even heard about it.
Mars 1.
A single radio signal from 140 million miles away changed everything, and then went silent forever. On November 1, 1962, the Soviet Union launched Mars 1, an 894-kilogram metallic behemoth packed with cameras, spectrometers, and enough scientific instruments to revolutionize our understanding of the Red Planet. This wasn't just another satellite circling Earth. This was humanity's first serious attempt to reach another world, and the Soviets were betting everything on it. The spacecraft was a marvel of 1960s engineering: solar panels that could function in the weak sunlight beyond Earth's orbit, a communication system designed to transmit data across interplanetary distances, and a heat shield capable of surviving the brutal journey through space. For 106 days, Mars 1 hurtled through the cosmic void, its trajectory perfectly calculated to intercept Mars during its 1963 closest approach to Earth. Soviet engineers monitored every signal, every telemetry reading, as their creation became the first human-made object to venture into deep space with a specific destination in mind. The mission was so classified that even NASA didn't fully understand what the Soviets had achieved until years later. But on March 21, 1963, at a distance of 65.9 million miles from Earth, Mars 1 transmitted its final signal, a weak radio pulse that faded into the cosmic silence. Radio Moscow never officially announced the mission's failure, but behind closed doors, Soviet scientists knew they had lost their first ambassador to Mars somewhere in the vast darkness between worlds, carrying with it humanity's first real dreams of interplanetary exploration.
Mars 2.
Two identical spacecraft sat on launch pads 3,000 miles apart, each carrying humanity's most sophisticated interplanetary technology, and both were about to become monuments to cosmic ambition and earthly miscalculation. The Soviet Union's Mars 1969A and Mars 1969B missions represented the pinnacle of Cold War space engineering, featuring advanced panoramic cameras, soil analysis equipment, and atmospheric sensors that could have rewritten textbooks about planetary science. These weren't simple flyby missions like their predecessor. These bus-sized spacecraft were designed to actually land on Mars and transmit the first close-up images of the Martian surface back to Earth. Soviet engineers had spent 3 years perfecting every component, from the retro rockets that would slow the descent to the shock-absorbing legs, designed to cushion impact on alien soil. The timing was critical. Mars and Earth aligned favorably for interplanetary travel only once every 26 months, and the Soviets knew NASA was preparing their own Mars missions for the same launch window. On March 27, 1969, technicians began the final countdown for Mars 1969A at Baikonur Cosmodrome. The 4-stage Proton K rocket stood 190 feet tall, its liquid oxygen and kerosene fuel tanks pressurized and ready. At exactly 10:40 Moscow time, the engines ignited with a roar that could be heard 20 miles away. For 51 seconds, everything went perfectly. The rocket climbed steadily through Kazakhstan's morning sky. Then, in an instant that would haunt Soviet space officials for decades, the entire assembly disintegrated in a fireball so massive it registered on seismographs across Central Asia.
Mars 1969.
The shockwave shattered windows 15 miles away, and in that single catastrophic moment, the Soviet Union lost not just a spacecraft, but their best chance at beating America to Mars. What should have been the triumphant launch of Mars, 1969A, instead became one of the most spectacular and most covered-up disasters in space exploration history. The Proton K rocket had barely cleared the launch tower when its third stage suffered a catastrophic engine failure, turning 500 tons of rocket fuel into an airborne inferno that painted the Kazakh sky orange for 37 seconds. Soviet officials immediately declared a media blackout. No photographs, no news reports, no acknowledgement that anything had even happened. but you can't hide an explosion visible from orbit. American spy satellites captured the entire sequence, watching as debris rained down across a 50-square-mile area of the Baikonur Cosmodrome. The blast crater measured 200 feet across and 30 feet deep, and radioactive fuel contaminated the launch pad for months. More devastating than the physical destruction was what burned up in that fireball. 7 years of Soviet Mars program development, millions of rubles in cutting-edge technology, and the careers of dozens of rocket engineers who were quietly reassigned to other projects. The backup mission, Mars 1969b, was indefinitely postponed as investigators sifted through the wreckage, trying to understand how their most reliable rocket had become a 3,000-degree funeral pyre for humanity's Martian dreams. Leonid Brezhnev himself reportedly watched footage of the disaster and declared that Mars missions were too dangerous to continue.
Mars 1971.
Against all odds and political pressure, Soviet engineers refused to surrender their Martian dreams. And on May 19, 1971, they launched what would become both their greatest triumph and most heartbreaking near miss in space exploration history. Mars 2 lifted off from Baikonur with the weight of the entire Soviet space program on its shoulders, carrying not just scientific instruments, but the redemption of a nation's cosmic ambitions. This time, everything went flawlessly. The Proton K rocket performed perfectly. The trajectory calculations were precise to within 0.001 degrees, and for 193 days, the spacecraft hurtled through space toward its December rendezvous with the Red Planet. Soviet Mission Control tracked every signal as Mars 2 became the first human-made object to successfully reach Martian orbit and deploy a functional lander. The 1,210-kilogram descent module separated perfectly, its heat shield glowing white-hot as it slammed into the Martian atmosphere at 13,000 miles per hour. But Mars itself had other plans. A planet-wide dust storm, the largest ever recorded, had been raging for months, turning the entire Martian surface into an impenetrable orange hurricane. The lander's parachute system couldn't compensate for the chaotic atmospheric conditions, and instead of the gentle touchdown Soviet scientists had dreamed of, Mars 2 crashed into the Christ-Planitia region at terminal velocity. In that devastating impact, the Soviet Union achieved a bitter milestone. They had successfully delivered the first human artifact to Mars, but it was now scattered across several square miles of alien terrain, silent forever.
Mars earthquakes.
The Red Planet is literally shaking itself apart, and the seismic data is so terrifying that NASA scientists are rewriting everything they thought they knew about planetary geology. On May 4, 2022, NASA's InSight lander detected something unprecedented, a magnitude 5.0 Marsquake that lasted over 6 hours and released energy equivalent to 32 billion joules, enough power to supply a small city for an entire day. This wasn't just another minor tremor, it was the most powerful seismic event ever recorded on another planet, and it revealed that Mars is far more geologically active than anyone imagined. InSight's ultra-sensitive seismometer had been listening to the planet's heartbeat for 1,318 Martian days, recording over 1,300 smaller Marsquakes, but this monster event shattered all previous records. The quake originated deep within Mars's interior, possibly from the Cerberus Fossae region, a network of massive fractures that stretch for thousands of miles across the planet's surface. What's truly mind-blowing is that Mars lacks the tectonic plates that cause earthquakes on Earth, meaning these violent tremors are generated by something else entirely. The planet's core is cooling and contracting, causing the entire Martian crust to crack like a drying mud puddle. French seismologist Philippe Lognon described the data as absolutely extraordinary, revealing that Mars experiences daily seismic activity that would terrify geologists if it happened on Earth. These discoveries completely overturn the old assumption that Mars is a geologically dead world, proving instead that it's a dynamic, evolving planet where the ground literally moves beneath your feet.
Mars subsurface lakes.
Buried beneath a mile of frozen Martian ice lies something that could, well, totally rewrite the search for extraterrestrial life. Liquid water lakes so vast they actually dwarf the Great Lakes, and they've been hiding there for millions of years. In 2018, Italian planetary scientist Roberto Orosai made a discovery that honestly sent shockwaves through the scientific community. Using radar data from the European Space Agency's Mars Express orbiter, his team detected a 12-mile-wide underground lake beneath Mars's south polar ice cap. This wasn't just frozen water or trace moisture. This was actual liquid water, maintained in its fluid state by a combination of geothermal heat from the planet's core and high salt concentrations that act like cosmic antifreeze. The radar penetration revealed what looks like a subglacial lake system, similar to those found beneath Antarctica's ice sheets, where Earth's most extreme organisms thrive in complete darkness. But here's where it gets truly extraordinary. Follow-up studies using Marcius radar discovered not just one lake, but an entire network of interconnected water bodies spanning hundreds of square miles beneath the Martian polar regions. Orosai's team published their findings in Science magazine, describing radar signatures so clear they're unmistakable. The bright reflections can only come from liquid water interfaces. These subsurface oceans have remained liquid for potentially billions of years, protected from Mars's hostile surface by thick ice and sustained by planetary heat. If life ever existed on Mars, these hidden lakes represent its last refuge, dark, salty sanctuaries where Martian microorganisms might still be thriving right now, completely unaware that curious humans are 140 million miles away, planning missions to drill down and say hello.
Mars organic matter.
The Martian soil is literally crawling with the building blocks of life, and the evidence is so overwhelming that NASA scientists are frantically recalibrating their entire approach to the search for extraterrestrial organisms. On September 15, 2022, NASA's Perseverance rover made a discovery that sent ripples through the astrobiology community. Organic compounds embedded within Martian rock samples from the Jezero crater, a 28-mile-wide ancient lake bed that once held liquid water for millions of years. These aren't just trace amounts of carbon. We're talking about complex organic molecules including aromatic compounds and aliphatic chains that form the fundamental chemistry of life as we know it. Perseverance's Pixel instrument detected these compounds using X-ray imaging and spectroscopy, revealing organic concentrations 10 times higher than anything previously found on Mars. NASA astrobiologist Amy Williams described the findings as unprecedented, noting that the organic matter is preserved within sedimentary rocks that formed when Jezero crater was a thriving ancient lake ecosystem. What makes this discovery truly extraordinary is the variety and complexity of the organic compounds. They're not random carbon molecules but structured chemicals that could only form under specific environmental conditions. The rover's samples contain nitrogen-bearing organics, sulfur compounds, and hydrocarbon chains that mirror the chemical signatures found in Earth's oldest fossils. Thomas Zurbuchen, NASA's former associate administrator, called it the strongest evidence yet that Mars once supported conditions favorable to life. These organic treasures are now sealed in titanium tubes, waiting for the Mars sample return mission to bring them home for detailed laboratory analysis that could finally answer humanity's ultimate question.
Moxie.
Deep in the Martian wilderness, a toaster-sized machine is quietly performing alchemy, converting the alien atmosphere into breathable oxygen, and proving that humans might actually survive on the red planet without suffocating in 96% carbon dioxide. NASA's MOXIE experiment, or Mars Oxygen In Situ Resource Utilization Experiment, aboard the Perseverance rover, has been working Martian magic since April 20, 2021, splitting CO2 molecules apart and creating pure oxygen at a rate of 5.4 grams per hour, enough to keep an astronaut alive for 10 minutes of normal breathing. This isn't just a cool science demonstration, it's humanity's first successful attempt at living off the land on another planet. The Golden Box uses a process called solid oxide electrolysis, heating Martian air to 1,470 degrees Fahrenheit and using electrical current to separate oxygen atoms from carbon dioxide molecules. Over 16 successful runs, MOXIE has produced a total of 122 grams of oxygen, more than 4 hours worth of breathable air for a single astronaut. MIT's Michael Hecht, the experiment's principal investigator, described the results as absolutely remarkable, noting that the device has consistently produced high-purity oxygen despite Mars's wildly fluctuating atmospheric conditions and temperature swings of over 170 degrees Fahrenheit. The implications are staggering. A scaled-up version of MOXIE could produce enough oxygen to fuel rocket engines for the return trip to Earth, eliminating the need to transport massive fuel tanks across 140 million miles of space. Mars is literally providing the life support systems that future human colonists will need to survive.
NASA SpaceX.
The ghosts of Soviet failure are now guiding humanity's greatest space partnership toward Mars, as NASA and SpaceX prepare to land the first humans on the Red Planet, using hard-won lessons written in the wreckage of decades of cosmic disasters. Elon Musk's Starship program isn't just ambitious engineering, it's the direct descendant of every Soviet Mars mission that exploded, crashed, or vanished into the cosmic void. The failures of Mars, 1969A, the heartbreak of Mars 2, and the seismic discoveries of InSight have created a roadmap of exactly what not to do when attempting interplanetary colonization. NASA's Artemis program and SpaceX's Mars architecture incorporate Soviet-era lessons about atmospheric entry, landing systems, and long-duration spaceflight that cost the USSR billions of rubles and countless careers to learn. The partnership officially began with commercial crew missions to the International Space Station, but the real target has always been Mars. NASA Administrator Bill Nelson and Elon Musk have committed to landing astronauts on Mars by the 2030s, using Starship's 100-ton payload capacity to transport everything from habitat modules to MOXIE-derived oxygen production systems. The Raptor engines that will power Starship to Mars burn methane and oxygen, the exact same fuel combination that can be manufactured on the Martian surface using atmospheric processing technology pioneered by failed Soviet experiments. What began as Cold War competition between superpowers has evolved into humanity's unified effort to become a multi-planetary species, built on the foundation of Soviet sacrifices that almost nobody remembers. That's the untold story of humanity's first Mars missions, Soviet secrets that almost changed history. From catastrophic explosions to accidental landings, these declassified missions proved that our journey to the Red Planet started decades before anyone realized. The courage of Soviet engineers and the lessons from their failures are literally powering today's Mars exploration. If this hidden space history blew your mind, smash that subscribe button and hit the bell icon so you never miss our cosmic secrets. Comment below. Which Soviet space mission shocked you the most? More space facts coming your way, space explorers. On September 26, 2022, NASA's DART mission slammed into asteroid Dimorphos, shortening its orbit by 32 minutes, a jaw-dropping 26 times the shift scientists predicted. We didn't merely tap a space rock, we rewrote the playbook on planetary defense in a single, spectacular collision. Earth just proved it can shove mountains in the vacuum of space. Will we do it again when everything's on the line? Did you know one well-aimed kinetic strike could steer a city-killer asteroid clear of our planet?
The DART mission.
Space debris just became humanity's new superpower. What started as NASA's most ambitious planetary defense experiment turned into the discovery that could save our planet from extinction. On September 26, 2022, the DART spacecraft slammed into asteroid Dimorphos at breakneck speed, traveling 370 million kilometers from Earth to execute what many called humanity's first real-life superhero moment. But here's where everything went beautifully wrong. Instead of the predicted tiny 73-second orbital shift, something absolutely mind-blowing happened that left scientists speechless and completely rewrote the rules of planetary defense. The double asteroid redirection test wasn't just about proving we could hit a cosmic rock the size of a football stadium. This was our species taking its first serious swing at playing cosmic billiards, testing whether we could actually nudge a potentially dangerous asteroid off course before it ruins everyone's day. Launched back in November 2021, DART had one job: crash into Dimorphos, the smaller moon orbiting the larger asteroid Didymos, and see what happens when human engineering meets ancient space rock. Scientists expected a gentle nudge, a small proof of concept that might buy us some confidence for future planetary threats. What they got instead was a masterclass in cosmic physics that exceeded their wildest calculations and fundamentally changed how we think about defending Earth from asteroid impacts.
Impact results analysis.
The cosmic equivalent of hitting a home run when you were just trying to bunt. When the dust literally settled after DART's kamikaze mission, astronomers pointing their telescopes at Dimorphos couldn't believe what they were seeing. The Hubble Space Telescope and ground-based observatories worldwide detected something that made every planetary scientist do a double-take. This wasn't the gentle tap they had modeled in their computers. The asteroid's orbital period had shifted by an astronomical 32 minutes, not the modest 73 seconds they had predicted. That's like expecting to move a boulder an inch and accidentally launching it across the parking lot. But here's where the real detective work began. The impact results analysis revealed that Dimorphos had essentially turned into a temporary comet, spewing out a massive debris plume that acted like a natural rocket engine. This wasn't just impact physics. This was discovering that asteroids could become their own propulsion systems when hit just right. The momentum transfer was 26 times greater than expected, meaning NASA had accidentally stumbled upon a planetary defense cheat code. Scientists frantically recalculated everything they thought they knew about asteroid deflection, realizing that a relatively small spacecraft could potentially redirect city-destroying space rocks with far less effort than anyone had dared hope. The implications were staggering. Humanity's cosmic insurance policy had just gotten a massive upgrade, and all it took was one perfectly executed space crash.
Momentum enhancement discovery.
Sometimes the most incredible discoveries happen when your experiment works too well. The momentum enhancement discovery from DART's impact wasn't just a pleasant surprise, it was a complete game changer that sent shockwaves through the planetary defense community. When scientists analyzed why Dimorphos got knocked around like a cosmic pinball instead of just gently nudged, they uncovered physics that Hollywood couldn't have written better. The secret ingredient? That spectacular debris cloud wasn't just pretty space fireworks, it was functioning as an improvised rocket engine, blasting material away from the asteroid and creating additional thrust that multiplied the deflection effect beyond anyone's wildest dreams. This momentum enhancement effect revealed something extraordinary about how kinetic impactors actually work in the real universe versus computer simulations. The ejected debris acted like exhaust from a rocket, pushing Dimorphos in the opposite direction with tremendous additional force. It's like throwing a baseball and having it somehow gain speed mid-flight. Completely counterintuitive but absolutely real. The 26-fold multiplication of expected results meant that future planetary defense missions could potentially redirect dangerous asteroids using much smaller spacecraft than previously thought necessary. Scientists realized they had witnessed something that could revolutionize how humanity approaches asteroid threats. Instead of needing massive, expensive missions to deflect city-killer asteroids, relatively modest spacecraft could potentially do the job thanks to this newly discovered physics phenomenon. The universe had just handed humanity a cosmic cheat code for planetary defense, wrapped up in the most successful space crash in history.
Asteroid structure insights.
Some asteroids are basically cosmic sandcastles waiting to fall apart. The asteroid structure insights from DART's encounter with Dimorphos completely shattered our assumptions about what these space rocks are actually made of. When mission scientists dove deep into analyzing why the impact was so devastatingly effective, they discovered that Dimorphos wasn't the solid, monolithic boulder they had expected. It was what researchers now call a rubble pile, essentially a loose collection of rocks, dust, and debris held together by nothing more than weak gravitational forces. This revelation explained everything about the spectacular 32-minute orbital change and why the debris plume was so massive. Think of it like the difference between hitting a concrete wall versus a pile of gravel. The energy transfer is completely different. When DART slammed into this cosmic rubble pile, it didn't just create a neat crater like punching solid rock. Instead, it excavated enormous amounts of material, launching chunks of Dimorphos into space and creating that dramatic comet-like tail that telescopes tracked for weeks. This discovery fundamentally changed how scientists classify near-Earth asteroids and assess potential planetary threats. The loose structure meant that kinetic impacts could be incredibly effective against similar rubble pile asteroids, potentially making planetary defense missions far more successful than anyone had dared hope. But it also raised new questions. How many potentially dangerous asteroids share this loose, fragmented structure? The answer could determine whether future deflection missions are routine procedures or complex engineering challenges requiring completely different approaches.
Strategic implications.
One successful space crash just upgraded humanity's survival odds by millions. The strategic implications of DART's overwhelming success rippled through every space agency and planetary defense program on Earth, fundamentally reshaping how we approach the cosmic threat of asteroid impacts. When the momentum enhancement discovery proved that deflecting dangerous asteroids could be 26 times easier than previously calculated, it wasn't just a scientific breakthrough. It was a species-level game changer that moved us from theoretical planetary defense to proven, practical capability. Military strategists, space engineers, and government officials suddenly realized that protecting Earth from city-killer asteroids might not require the massive, expensive missions they had been planning for decades. The implications extend far beyond just building bigger rockets or spending more money. This discovery means that relatively small, affordable spacecraft could potentially redirect near-Earth objects that pose existential threats to human civilization. Space agencies worldwide began recalculating their planetary defense budgets, realizing they could potentially defend against multiple asteroid threats with the same resources previously allocated for single missions. The kinetic impactor technique went from experimental concept to proven technology overnight, giving humanity its first real planetary defense weapon that actually works better than designed. But perhaps most importantly, the success demonstrated that we don't need decades of warning to mount an effective defense. The momentum enhancement effect means faster, more responsive missions could potentially handle threats detected with shorter lead times, dramatically improving our cosmic security posture.
Hera mission planning.
The real investigation starts now. While DART proved that humanity can successfully punch asteroids off course, the European Space Agency wasn't about to let this cosmic crime scene go unexamined. Enter Hera mission planning, the detective work that will finally reveal exactly what happened when our spacecraft obliterated Dimorphos, and why the results were so spectacularly beyond expectations. Scheduled to launch in 2024, this follow-up mission will arrive at the Didymos system in 2026 to conduct the most detailed forensic analysis of an asteroid impact in human history. Think of Hera as the cosmic CSI team, arriving to photograph the crater, measure the debris, and piece together every detail of humanity's first successful planetary defense demonstration. But Hera isn't just satisfying scientific curiosity, it's gathering critical intelligence for future planetary defense missions. The spacecraft will precisely measure Dimorphos's mass, analyze the crater's dimensions, study the asteroid's internal structure, and determine exactly how much material was ejected during impact. This data is absolutely crucial because the next time we need to deflect an asteroid, it won't be a test. It could be the difference between civilization and catastrophe. Hera's findings will help scientists understand whether the momentum enhancement effect was a lucky accident or a predictable phenomenon that can be reliably reproduced. Armed with this knowledge, future deflection missions can be planned with surgical precision, ensuring that when humanity faces a real cosmic threat, we'll know exactly how hard to hit it.
Planetary defense evolution.
From asteroid hunters to cosmic guardians in just one successful crash. The planetary defense evolution triggered by DART's triumph represents the most significant shift in humanity's approach to cosmic threats since we first started tracking near-Earth objects. Before September 2022, planetary defense was largely theoretical. Scientists could model asteroid impacts, calculate trajectories, and propose deflection strategies, but nobody actually knew if any of it would work when push came to shove. Now, with real data proving that kinetic impactors are devastatingly effective, space agencies worldwide are completely rewriting their threat assessment protocols and emergency response procedures. The momentum enhancement factor isn't just being incorporated into computer models, it's fundamentally changing how we categorize asteroid risks and allocate planetary defense resources. This evolution goes beyond just updating equations and mission plans. Countries that never had serious planetary defense programs are suddenly investing in asteroid detection networks and deflection capabilities. The International Space Station partners are collaborating on advanced warning systems, while private companies are developing rapid response spacecraft that could be deployed within months rather than years. The success has also accelerated development of next-generation asteroid hunting telescopes and improved orbital prediction algorithms. Most importantly, the psychological shift is enormous. Humanity has moved from passive observers of cosmic threats to active defenders of our planet. We're no longer just hoping that dangerous asteroids will miss us, we now have proven technology to make sure they do. The age of planetary defense isn't coming someday. It arrived the moment Dimorphos got knocked sideways by human ingenuity.
Mission success redefinition.
Success isn't always about hitting your target, sometimes it's about completely redefining what success means. Mission success redefinition became the most unexpected outcome of the entire DART program. fundamentally changing how space agencies measure achievement in planetary defense missions. Before impact, NASA had already declared the mission a triumph simply for demonstrating that humans could accurately navigate a spacecraft across 370 million kilometers and hit a target the size of a football stadium. The primary objective was purely technological: prove the guidance systems work, test the kinetic impactor concept, and measure any detectable change in Dimorphos's orbit, no matter how small. Mission planners would have celebrated even a 10-second orbital shift as groundbreaking proof of concept. But the universe had other plans. When the 32-minute orbital period change was confirmed, it didn't just exceed expectations, it obliterated every benchmark scientists had established for what constituted mission success. This wasn't incremental progress, it was a quantum leap that forced mission planners to completely recalibrate their success metrics for future planetary defense operations. The 26-fold enhancement over predicted results meant that DART had essentially accomplished what multiple missions were designed to achieve. Space agencies worldwide began questioning whether their own success criteria were too conservative, whether they were underestimating human technological capabilities, and how to properly set goals for missions venturing into uncharted scientific territory. The redefinition cascaded through every future mission proposal, with engineers now expected to plan for spectacular success rather than modest achievement.
Debris management and safety concerns.
What happens when your successful space mission accidentally creates a cosmic mess? The debris management and safety concerns following DART's spectacular impact revealed that planetary defense isn't just about hitting asteroids, it's about dealing with the aftermath of turning space rocks into temporary comets. When Dimorphos got walloped on September 26, 2022, it didn't just change its orbit, it transformed into a debris-spewing machine that kept astronomers busy for months tracking every chunk of ejected material. Ground-based observatories worldwide suddenly found themselves monitoring a massive cloud of asteroid fragments spreading through space, creating an unprecedented challenge in space situational awareness and collision risk assessment. The spectacular debris plume that made DART so successful also raised serious questions about future deflection missions near critical space infrastructure. The ejected material created a comet-like tail visible through telescopes for weeks, with chunks of Dimorphos scattered across thousands of kilometers of space. Mission controllers had to carefully track this debris field to ensure it posed no threat to other spacecraft operating in the region, while also studying its behavior to improve debris modeling for future planetary defense operations. This unexpected consequence highlighted a crucial gap in mission planning. While everyone focused on successfully deflecting the asteroid, nobody had fully anticipated the complexity of managing the resulting space debris. The lesson was clear. Future deflection missions targeting asteroids closer to Earth or near valuable satellites will need sophisticated debris mitigation strategies to prevent turning one cosmic threat into dozens of smaller ones.
Precision requirements for real threats.
Practice makes perfect, but real asteroids don't give you second chances. The precision requirements for real threats expose the sobering reality behind DART's celebration-worthy success. While humanity proved we can deflect asteroids, the margin for error when facing actual Earth-threatening objects is absolutely zero. Unlike the controlled experiment with Dimorphos, where scientists had years to plan and could afford to overshoot their deflection goals, a genuine planetary defense scenario demands surgical precision that accounts for every variable imaginable. The momentum enhancement effect that made DART so spectacularly successful also introduced a new layer of complexity. Future deflection missions must accurately predict how much debris each target asteroid will eject, because the difference between nudging a space rock safely away and accidentally hurling it toward a populated area could determine the fate of millions. The challenge intensifies when considering that every potentially hazardous asteroid has unique characteristics that could dramatically affect deflection outcomes. Rubble pile asteroids like Dimorphos might respond completely differently than solid metallic objects, icy comets, or loosely bound dust clouds. Mission planners now face the daunting task of developing deflection strategies that work across this entire spectrum of cosmic threats, all while operating under the pressure that failure means catastrophic impact. The years of advance warning required for successful deflection means that asteroid detection networks must identify threats earlier and with greater accuracy than ever before. One miscalculation in trajectory, timing, or target composition could turn humanity's greatest technological achievement into its most devastating mistake. That's how NASA turned one perfectly executed space crash into humanity's greatest planetary defense breakthrough. The DART mission didn't just prove we can protect Earth from asteroid threats, it showed us we're way better at cosmic billiards than anyone dared hope. But this is just the beginning of our journey into the incredible world of space exploration and planetary defense. If you love discovering how we literally punched an asteroid off course, smash that subscribe button and hit the bell icon so you never miss the latest mind-blowing space facts. Drop a comment below. What space mission do you want Space Facts to cover next? The universe is full of incredible stories, and we're just getting started.